In this video, we're going to look at how to use the greatest common factor to factor an expression. So first of all, let's distinguish these two types of questions. So one of them is called multiply. So when we are given two numbers, 2 times 3, we supposed to multiply them to get the answer, which is 6. But for a factoring problem, we are given the number 6, and we're supposed to break it down as 2 times 3 if we only consider prime numbers. So as you can see, these two types of problems, they reverse each other. The answer of multiplication problem is the problem and of a factoring, but the problem actually is the answer. As you can see, the answers and the questions, they are switched. And so factoring problem, which we did it before, are asking us to break down a number. So now we're going to see how to break down an expression. So again, these are two types of questions. So a problem we did previously is if we are given x times parentheses of x minus 5, we know that in order to get rid of parentheses, we have to distribute outside the parentheses, which is x. So we're going to do x times x, which is x squared. And then we're going to do x times negative 5, and then we get 5x. So we're going to move 5 and put in front of x. Usually we like to write numbers first before, put numbers before the variables. So that would be the answer, x squared minus 5x. And of course, it's more complicated than multiplying numbers when we multiply expressions. So similarly, when we reverse this process of multiplication, so which is called factoring, it's going to be more difficult. So when you see here, if we are given x squared, the answer x squared minus 5x, and we are asked to break it down as something times something. Of course, from the problem, we know it should be x times 5 times x minus 5. But how did we get this? How do we reverse this back to x times x minus 5 without seeing the original multiplication problem? So this is what we're going to talk about here, the first type of factoring. And so because factoring is reversing multiplication, so if we understand multiplication, how the process works, it will help us do factoring, because it's trying to reverse every step. So let's start with the multiplication problem, which we talked about in chapter 5. So let's say if we ask to multiply 3a times 5a plus 4b, we are going to distribute 3a to everything in parentheses. So we're going to do 3a times 5a plus 3a times 4b. So the red one, we made 2 copies, one for the first item in the parentheses and the other for the second term. And now we're going to multiply 3a and 5a. And we know when we multiply the number and number. 3 times 5 is 15, and a times a is a squared. Same thing here, 3 times 4 is 12, and a times b is ab. So that's the answer. But if we are given 15a squared plus 12ab, and we are trying to figure out what times what can give us the answer. So we're going to look at the multiplication part, how we end up with this answer, 15a squared plus 12ab. So if we look at the previous step, and notice that they are obtained from multiplying 3a with both of the 2 terms from the parentheses. So notice that 3a is multiplied into with something else, either 5a or 4b, and now we get 2 new expressions. So because notice right now in the final answer, we don't really see 3a anymore because they're multiplied in there already. But what we need to be able to do first is to pull 3a out. But if we don't see them in here anymore, since they are multiplied with something else, how do we see 3a? So that's going to be using what we talked about in the previous video, how to find the GCF of 2 expressions. And remember that when we can use the factoring method, of course, if you can look at the number 15 and 12 and realize 3 is the greatest common factor, you write down 3. And then you look at a squared and a, they both have a in common, take the lowest exponent. And one of them has b, the other doesn't, so they don't have b in common. So you can get the GCF 3a immediately. But if you cannot do that by looking at these two expressions, you can find the answer by doing factoring. So that's why I did here. 15 breakdown as 3 times 5, a squared as 8 times a, 12 as 3 times 2 times 2, and a, b, we cannot break down a, so write down a. We cannot break down b, write down b. Actually, I probably should move this b a little bit over because I kind of ran out of space. So maybe you can consider these are two separate columns. And so now you can look for a number or variable that is contained in both of the expressions. As you can see, the two columns highlighted, they both have two numbers, 3 and a. So that means 3 are contained in both of the expressions, and a is also contained in both expressions. So when we put 3 and together, we get the greatest common factor, 3a, which matches what we just got. So as you can see, although we don't see 3a in both of the expressions, we can use factoring to figure out 3a, what they have in common. So after we figure out the greatest common factor 3a, so we're going to write it down. We got one of the factors. So because when we break down, usually we have 2, but of course sometimes we could have 3 or 4. For example, when we break down 12, we get 2 times 2 times 3. But in this case, we are just going to get 2. So notice that I already got one of them, which is 3a. I just need to figure out the other. Okay. And in order to do that, we're going to go back to the multiplication process and try to reverse that. So notice that 15a squared, this first term here, is obtained by multiplying 3a and 5b. So maybe I'll just do this. So 15, focus on 15a squared. This comes from multiplying 3a and 5a. And that 5a is what we're looking for. So we need to look for, we already got 3a, which is the GCF. We need to find 5a and 4b. But notice that 15a squared comes from multiplying these two. So if we already know one of them, how do we find the other? So if I put this as a question mark, so it's like asking us 3a times what will give us 15a squared. And to help you understand the step, let's look at example with only numbers. So if you are asked 12 times one number is 36, we could use the opposite operation of multiplication, which is division. So we could divide 36 by 12, which will give us 3. So that means 12 times 3 is equal to 6. And again, we're reversing multiplication. So we supposed to reverse multiplication, which is division. So similarly, here we are given, this is what we're given, 15a squared. And we use the factoring to figure out the GCF, which is 3a. So now we just need to figure out 3a times what equals 15a squared. Again, why we're doing that, it's because we're trying to reverse the steps here. If we are given this, how do we find this 5a? Okay, so we are very similarly, we could, just like we did divide 36 by 12, we would divide 15a squared by 3a. So we're going to divide whatever this is given by the GCF 3a. And we learned how to divide monomials before, so we divide 15 by 3 to get 5, a squared divided by a to get a. Subtract exponents, 2 minus 1 is 2, is 1. So now we figured out 5a. Again, 3a times what is 15a squared? That's 5a. Similarly, let's see what will give us that. How did we obtain this 12ab? And from the previous process, we see that we actually multiply 3 and 4b. But right now, we don't know what 4b is. So pretend we don't know that. So it's kind of like asking us 3a times what will give us that 12ab. And again, we're doing the division. And so we take 12ab divided by 3a. So we divide 12 by 3, it's 4. A cancels a, and we're left with b. So we figure out that's 4b. Again, between them, it's a plus. Because you notice that plus sign, when we do the multiplication, the plus sign is kept from the beginning to the end. So here, when we reverse the process, if we had a plus sign, you will still have plus sign in the parentheses. So now you can see that's how we found the factoring. And summarize the steps here. So step one, we will find the GCF of these two expressions. If we're given 2, if we were given 3, we have to find the GCF of all 3. So step 1. Step 2, we did a division here. So we're going to divide whatever expression is given by the GCF. So that will give us 5a, and we also keep the sign between them. And the answer consists of two factors. The first factor is the GCF. The other is whatever we get after we're doing division. So let's look at another example. So in this case, first we look for the GCF, and notice that if you may have to do this if you cannot see the answer directly. Break down 25, break down 10. Actually, this time I did something a little different. So I look for the GCF of 25 and 10. Again, if you can see the answer is 5, you don't have to do this. Okay. And then I break down a third and a, and I found out they have a in common. So the tip that I gave you in previous video is that you always use the lowest exponent. Compare 1 and 3. 1 is smaller, so so first of all, 25 and 10, they have 5 in common. And a third and a, they have a in common. Just like 3 copy and 1 copy, they have 1 copy in common. And b squared and b third, and they have take the lowest exponent, so you get the answer immediately. But it matches what we got with the factoring method. So as you can see, they both have actually 2 b's in common. I didn't highlight the other b. So I highlight this b. So they have 2 b's in common. The answer is b squared. Okay, but again, if you can just see the answer directly, you don't have to do the factoring. So first of all, so this is our first step. We figured out the GCF is 5ab squared. We found one of the factors. Now we need to determine the other factor, again in the parentheses. And notice the original problem has plus, so it's going to be plus here in the parentheses. So how do we determine these two? And remember, factoring is reversing multiplication. So we're going to do the inverse multiplication, which is division. So we're going to take, in order to figure out this, so how do we get that from multiplication? And we multiply 5ab squared with something to get that. So which means we have to divide 25a third b squared by the GCF that we got in order to get the answer for that. So after division, 25 divided by 5 is 5, a third divided by a is a squared, because 3 minus 1 is 2, and b squared cancels b squared. So we found the answer here, which is 5a squared. Now, how do we get this from multiplication? Again, we multiplied 5ab squared with something, and that something can be found by dividing the answer by the GCF. So 10ab squared cubed divided by the GCF 5ab squared. So we divide 10 by 5, it's 2, a cancels a, b cubed divided by b squared is b, because 3 minus 2 is 1. So we got 2b here for the second factor. So that would be the answer. Again, the answer of factoring should be something times something. Just like we see previously here, the answer is something times something. Or like the factoring of a number, it's a number times another number. Now we look at another example. In this case, we have 3 expressions. But first, we're still going to look for the GCF, 54, 15, and 42, see what they have in common. And so again, if you can see that 3 goes into all of them, so you get 3. If you can't, you have to do the breakdowns. So I can do the breakdowns a little quick here. So 54 is 2 times 3 times 3 times 3. Because 54 actually is 2 times 27, but 27 can be broken down as 3, 3, 3. So if you need help with the factoring tree, you can do this. So you get 2, 3, 3, 3. And 15, this is 3 times 5. So line up 3 and 3 and create a new column for 5. And 42 is 2 times 21, and 21 is 3 times 7. So we got a 2 to line up with the 2 we already have. And the factor 3 line up with the 3, and the 7 create a new column. So notice that 3 is the only thing they have in common. So if you cannot see that, and use the factoring. So that's how I found the 3. Next, for the variables, that would be easy. So you just look at all the A's, see what they. Well, unfortunately, the last one doesn't have a. So they don't have any A in common. So there will be no A's in the GCF. Now let's look at the B's. So we have a B third, B squared, and B. We take the smallest exponent, which is first, and so they all have 1 B in common. So again, B third has 3 copies, B squared has 2 copies, B only has 1 copy, so they only have 1 copy in common. So that's our step 1. Once you found this, the GCF 3B, that's one of the factors. Now we're going to find what's in the parentheses, and notice between it's all pluses, so you can go ahead and bring down the pluses. And now we are going to figure out what these 3 terms will be after multiplying with 3b. That will give us the expressions. So first, remember we are reversing multiplication. We're going to do division. So literally, I saved some space here so I don't have to rewrite these. So I can just put 3b down here, divide by 3b, divide by 3b, and divide by 3b. Now 54 divided by 3, that's 418. And a fourth, I bring it down because there's no a to divide. B third divided by b first, that gives me b squared. 3 minus 1 is 2. Next, 15 divided by 3 is 5. There's nothing to divide with a. And b squared divided by b, that gives us b. 2 minus 1 is 1. Finally, 42 divided by 3, that's 14. And b cancels b, so we don't have any letters for this, just the 14. So that would be the final answer. And for the factoring questions, if you have time, you can always check your answer on your scratch. So how do you check your answer? What you can do is, again, you don't have to show me this, but you can do this on your scratch paper. So because we just reversed the multiplication to get this multiplication expression. So if we actually multiply this answer we got, if we multiply out by distributing 3b, it should go back to the problem that's given. So for example, 3 times 18 is 54, and b times b squared is b third, and a fourth we just bring down. So we're multiplying 3b and 18 a4b squared. That gives us that. And then you multiply 3b with the 5ab. That gives us 15ab squared. And finally, you multiply 3b with 14. That gives us 42b. And if you, after you multiply your answer out, if you can go back to this matches the problem given, and that tells you your factoring is correct. If it doesn't go back to the problem given, that means your answer is wrong.